Welcome back, amazing students of Oshkosh North High School. Today we are going to be looking at AP Stats Lesson 5.3. We're going to be talking about conditional probability. We'll talk about dependent and independent events. We're also going to utilize some two-way tables to enhance your learning. So let's go ahead and get started. Hey, guess what? We're going to be doing more of the taco tongue and evil eye for this one. So are the events yes taco tongue and yes evil eye independent? All right, well, they're going to have us figure out the answer to that, but first of all, we have to fill in the data. So here we go. This is our data. This is our data. We had this last time. Our data for taco tongue, yes taco tongue and yes evil eyebrow is 15, yes for taco tongue and no for evil eyebrow is 5, no for taco tongue and yes for evil eyebrow is 3, no for taco tongue and no for evil eyebrow is 7. So if you add them together, there's 20 people that were yes for taco tongue. There are 10 people that were no for taco tongue. Reading the other way, because it's a two-way table, for yes for evil eyebrow is 18 and no for evil eyebrow is 12. Notice how both the row and the column add up to the same number. That should always happen. So suppose we randomly choose a student from the class. So we're going to pick one of these 30 students. What is the probability that they are yes for taco tongue or yes for evil eyebrow? Okay, well, there's two ways to do this. I'm going to show you the box method first, which is not the way we're going to learn how to do it, but this is a way that you could do it if you didn't know anything about the formulas. So yes for taco tongue or yes for evil eyebrow. That would be yes for taco tongue here and yes for evil eyebrow there. So it's everybody except for these 7. So 30 minus 7 is 23, so it'd be 23 out of 30. But we want to deal with our conditional probability formulas. So here's how we would deal with that. So find the probability of yes for taco tongue or yes for evil eyebrow. That'd be the probability of A or B, with A being yes for taco tongue and B being yes for evil eyebrow, which would be the probability of A plus the probability of B minus the probability of A and B both happening together. So you've got your 20 out of 30, which is here. That's your yes for taco tongue, 20 out of 30. Then you've got your 18 out of 30, which is your yes for evil eyebrow, 18 out of 30. Then you minus both, the yes for both. This was yes for both, 15 out of 30. And you get 23 out of 30. And that's how you figure out the conditional probability. Number 3, given that the person selected is a yes evil eyebrow, what is the probability that they are a yes for taco tongue? Write a fraction, a decimal, and a percent. Okay, so we're given that they are a yes for evil eyebrow. So let's figure out what that's talking about in our chart. Yes for evil eyebrow would be these numbers right here. So we're just working with this column. We're not working with the evil eyebrow right now. We're just working with those. So given the person is selected as a yes for evil eyebrow, what is the probability that they are a yes for taco tongue? So we're just doing these 18. Yes for taco tongue is 15 out of 18. 83%. That's your conditional probability. This symbol means given. So this means the probability of yes for taco tongue given that it was a yes for evil eyebrow. And that's your condition. Question number 4, given that a person selected is a no evil eyebrow, so that would be this column right here, no evil eyebrow. What is the probability that they are a yes for taco tongue? Rate as a fraction, decimal, percent. Okay, so the probability that they are, or we're given that they're a no evil eyebrow, the probability that they're a yes for taco tongue is this one. So that's 5 out of 12, 5 out of 12. And this would be your decimal representation and your percent representation. So the way that you would read this is the probability of yes for taco tongue given no for evil eyebrow. Now we're ready for the definition of two independent events. Two events are independent if knowing whether or not one event has occurred does not change the probability that the event will occur. So did knowing one change the other? Are the events yes taco tongue and yes evil eyebrow independent? Does that mean that the probability of one is not affected by the conditional probability of the other? Well, the answer there, my friends, is no. People who can evil eyebrow are more likely to taco tongue. We can see it here in the stats. If they can evil eyebrow, yes for evil eyebrow, they're a lot more likely that they can also taco tongue than not. So nope, not independent, not independent. Let me give you a money sample. So let's say you got all these boxes. Okay, we'll kind of make it like Deal or No Deal. You got 30 boxes, and you got 30 people. Let's say that these people are all sitting in a row and they've each got a box, and one of the boxes has $1 million in it. Okay, well, you're going to play the game, and maybe you've played it a couple of times, and they say, well, what's the probability that your box contains the $1 million, given that in the last game, your box did not contain the $1 million? Well, it's a brand new game. We're starting over 30 new boxes, so your probability is still 1 out of 30. However, see if you can follow the logic here. This one would be dependent. That one was independent because it didn't change. If from one game to another, your probability was still 1 out of 30. But how about this? What is the probability that your box contains the $1 million, given that the two people sitting one on each side of you do not have the $1 million? Well, now that does change things. Instead of 1 out of 30, you would now be 1 out of 28, because you know this person doesn't have it, and you know that this person doesn't have it. So you now have a 1 out of 28 chance of having the $1 million. Hopefully that makes sense for you. Let's continue with our notes from our good friends at StatsMedic. So consider this data for all seniors at EKHS. Find each of the following using the data in the table, right, as a fraction, a decimal, and a percent. All right, we can do that, my friends. Here's the data. This is the data for EKHS. So the numbers are different. It's the same experiment. It's yes for taco tongue, no for taco tongue, yes for evil eyebrow, no for evil eyebrow. Same experiment. But their school is a little bigger, so their numbers are a little higher. All right, so let's take a look and see how you get these answers. Find each of the following using the data in the table, write them as a fraction decimal percent. That's what we're going to do. So first of all, the probability of yes for taco tongue. Yes for taco tongue is right here. There are a grand total of 480 students that have taco tongue. So that'd be 480 over 600, which is 80%. The probability of yes for taco tongue, given that it was first yes for evil eyebrow, then we're going to be looking at the yes for evil eyebrow. We're going to ignore this column, cover that up. We're just going to be working with this column, yes for evil eyebrow, and the yes for taco tongue is 180 out of 200, so that's 90%. Part C, probability of yes for taco tongue given no for evil eyebrow. So yes for taco tongue, but no for evil eyebrow is 300, and that's out of 400, so that's 75%. Are yes for taco tongue and yes for evil eyebrow independent? That means they would have to be the same whether evil eyebrow happened or not. Is yes for taco tongue the same whether or not evil eyebrow happens? No, it's not. It's different. So nope, sorry, they are not independent. Question number 7. Fill in the table as if the events were independent. So now we're going to say, okay, that's independent. 80% of our people have taco tongue, and 20% have or can't do taco tongue. So here's how we're going to fill this out. So yes for taco tongue, it's 80% of the 200. So we're just looking at this column. 80% of the 200 is 160. And then 40 is taking 20% of the 200. Okay, how about this column for the 400? Okay, you got 80% 320 times is equal to 80% times 400. This is the 400 here. And then 80 is your 0.2. So you've taken 80% times this and 20% times this, and you fill in the boxes. So that's if they were independent, Let's see if these match. So these add up to 200, these add up to 400. Let's see if it matches that way, because it should. 160 and 320 is 480, 40 and 80 is 120. So 80% who can taco tongue, 20% who cannot do the taco tongue. So find each of the following using the independent table, write as a fraction, a decimal, and percent again. So first one, just probability of A. First, just the regular event, yes for taco tongue. Yes for taco tongue was 480 out of 600, which is 0.8 or 80%. Now here's a conditional. Yes for taco tongue given yes for evil eyebrow. So now this one's going to be 160, which is yes for taco tongue, and 200 given yes for evil eyebrow, and then you divide them and you get your 80%. How about yes for taco tongue given no for evil eyebrow? Okay, you take your numbers, you divide them out. Wow, you get 80% again. These are all equal, and they should be, because we set it up so that it is independent. So your probability of getting taco tongue was 80%. Your probability of getting taco tongue, if you could do evil eyebrow, was still 80%. Your probability of doing taco tongue, if you couldn't do evil eyebrow, was still 80%. So whether or not you could do evil eyebrow had no effect whatsoever on taco tongue. So therefore, those two events are independent. Question number 9. What do you notice about your answers in 6 and 8? Well, in 6, all the probabilities are different, but in 8, they're all equal to each other. So here's our generalization. Complete the following statement using a formula. Here's your formula down here. Let A equal yes for taco tongue and B be yes for evil eyebrow. The probability of A is equal to the probability of A given B, which is equal to the probability of A given not B, or A given that B did not happen. And that brings us to our written notes section. Let's write these in, Oshkosh North students. Learning target number 2 is conditional probability. So the probability of A given B is the probability of A and B divided by the probability of B. And here's learning target number 3, independent. When knowing one event has occurred or has not occurred does not affect the probability of the second event. So just like we had in the last question. Okay, let's check for understanding, guys. And we got your Pew Research again. They randomly selected 100 mothers age 40 to 44 in 3 different years, 1976, 1994, and 2014, and asked each mother how many children they have. The 2A table summarizes the responses. So here you go. You got 1976, bigger families back in 1976. Look at that. 1994, not so much for the big families. In 2014, not as much either. So let's see what they're going to ask us for. It says, suppose we randomly select one of the survey respondents. Define event C. Now, event C is going to be having 4 or more children. And then event S would be 1976. If they want N, it's 1994. And if they want F, it's 2014. They want S. They want S. So they'll tell, the directions will tell you which column you're going to be looking at. And we want the S column. So we want the 1976. So the probability that C happens, what was it? What were the situation for C? Well, that was 4 or more children. So 4 or more children is 40. So that's 40 out of 100. There's 100 mothers surveyed in 1976. So that's 40%. So given the mother was surveyed in 1976, there's a 40% probability that she had 4 or more children. How about question 2? Given that the chosen mother was not surveyed in 1976, what's the probability that she has 4 or more children? Write your answer as a probability statement. Okay, so the probability that she has 4 or more children given the complement of S, so not 1976. So that means either 1994 or 2014. 1994 is 13 right here. And there you go. 2014 is 13 also. 13 out of 100, 13 out of 100. So that's 13 plus 13 or 26 out of 200, which is 13%. Hey, that's a big difference. Are the events surveyed in 1976 and four or more children independent? Nope. Mothers surveyed in 1976 are much more likely to have four or more children than the mothers not surveyed in 1976. So the probability that she has four or more children, given that it was asked in 1976, is not the same as the probability that she has four or more children if she was surveyed in 1994 or 2014. That, my friends, concludes our notes for today. Thank you for joining us. Stay awesome. Have a good day, and we'll see you next time.